Hello and welcome to HES's dealer webinar series. Today we're going to be going over the Radian and Mate 3 inverter and all of the applications that both of those products can benefit your solar system with. Mark Mays will be joining us. He's Outback's applications engineer. And Brian Douglas, our sales manager, will also be here to answer any questions. As far as questions go, if you could please, the format as per normal is we'll do the entire presentation. It will probably be about 45 minutes in total, and then the last 15 minutes we'll do a Q&A. So you can, and if there's an imperative question, you feel free to type it in, and we may answer it during, but probably answer it at the end of the presentation. So at this point in time, I'd like to pass over the controls to Mark Mays, Outback's application engineer.
Okay, thanks, Brian, and welcome everybody to today's webinar. And again, my name is Mark Mays, and we're going to talk about some Radian inverter applications and, of course, the Mate 3 user interface. How to use it as systems communications. We're going to talk about some new inverter operating modes that are available with the Radian, and some how to AC couple the Radian in with some grid tie inverters. And we're going to start off though with talking about the grid hybrid solution. Outback has been known for its off-grid inverters. But we came out with the Radian that is both an off-grid inverter and a grid interactive or grid tie inverter. And just a quick overview, the main design innovation we feel is the simplicity of installation. We've integrated the balance of systems into a load center you see here at the bottom. The top part is the inverter. There's just a back plate that mounts on with 4 lag screws. There's a little bracket on the back that just mounts over that. So it goes on very quickly. You can get the pre-wired versions that have the circuit breakers and our integrated bypass already pre-wired in there. You just land your field wires onto some screw terminals, and that's pretty much it. Other than you do have to pass a wire bundle up into the inverter here with some quick connects. You don't even need a screwdriver. They just go right in and you have to hit the quick connect to tie them down. So it's all designed to go for a fairly quick and easy field installation because time is not even in the field. And you can get also pre-wired versions that are pre-wired for up to 2 charge controllers to simplify that installation as well. One thing that's kind of unique about the architecture is there's just 3 modules inside of there. They run the whole length of the inverter. There's a control board stack and then 2 power modules. And that's it. So you got 3 modules in there. Power modules come out in less than a minute. The control board stack maybe a minute. So if you ever do need to service it, it's very, very simple to do. There's also dual AC inputs. We call them grid and gen. They're electrically the same, but this eliminates the need for an external transfer switch. And then we have some of these new input modes. So the grid hybrid system, it provides battery backup and selling to the grid. So many of you are familiar with, the grid tie inverter that has no battery backup. We had battery backup with our off-grid inverters. Now we have what we call a grid hybrid system. We've also called it grid interactive that provides battery backup and selling to the grid. And just for those of you that aren't familiar with battery-based systems, essentially we take the variable DC coming array, we convert it down and regulate it to the whatever battery voltage you're connected to, and then that renewable energy gets converted into AC power for the critical load center. Any load demand that can't be met from the renewable energy side would come in from the grid to supplement that. And likewise, if there's an excess of renewable energy, it's met the load demand and there's more, then it can offer that out to the grid as well. So this is what we call our grid hybrid system, and that's the best of both worlds. One of the things that we've done is we've come up with some new as well as improved input modes with our inverters. We have generator mode, which is a new mode, support, which is what we've had before but works in a little bit new way, grid tied, UPS is a new mode, some enhancements available with backup, and something we call the mini grid mode. So in the generator mode, we can take advantage of the dual input. So we have what we call a grid input and then a gen input. When we lose grid power, there's an internal transfer switch that isolates that grid input from the rest of the inverter. So you don't need to have an external transfer switch. Then on the gen side, we don't filter or condition the power. We just allow whatever power to go through as long as it meets the specifications of plus or minus 4 hertz, I believe it is, off of 60, and 108 to 140 volts. It meets that general kind of wide spec, and we will pass it through unfiltered and unconditioned. So this allows you to use noisy generators, if you will. A lot of loads can handle those generators fine. But the support mode and offset, which I'm going to talk about through next, and grid type functions, you do lose those. The Outback function is something that's really unique about the Radian inverter. And it's something we had with our grid tie inverters. And basically the way that it works is if you have renewable energy coming off the array and the batteries are full, in our off-grid modes like backup and mini grid and UPS, normally it's just going to sit there. It's going to float the batteries and energy kind of gets stuck at this point until you lose power. Now in an off-grid mode, we have a generator out here. You know, when the generator shuts off, then okay, everything comes on, everything's fine. But when you're hooked up to the grid, it's just going to sit there. You're in backup mode. Well, so what we have is we have this thing, this function called offset. It's just there. It's not. You can't turn it off or on. And what's going to happen? Let's say you're just in like a backup mode, and you have 30 amps of load demand, but only 20 amps available from your renewable energy. It's going to mix that 20 amps with 10 amps from the grid, and that's going to give you meet your 30 amp load demand. But let's say all of a sudden you get more renewable energy, and this goes up to 30 amps of renewable energy, and it's going to disconnect from the grid completely, and it's going to offset that load demand, if you will, which is kind of nice. You're not stranding all this energy. I know in some, I think in Ontario, they don't allow battery-based systems, and I think part of that issue is that they don't fully understand, you know, how our rating might work. So, and we're working with some utilities here because a lot of utilities don't understand battery-based inverters, but with this offset function, it allows you to stay connected to the grid without putting energy out onto the grid, but you're not stranding that renewable energy because you're allowing your loads to consume it. So the target voltage is the cell voltage, normally around 52 volts. So it could be charge voltage too. So we can be charging the batteries and pushing renewable energy out to help meet load demand and reduce the amount of energy that's coming from the grid. And it will disconnect from the AC source if the renewable energy meets or exceeds the load demand. So this is really a very nice feature, very innovative feature in our Radian. We also have support mode, and basically the support mode, it's used to augment the AC input source. For example, let's say you had a 40 amp generator, or maybe a 40 amp limit on your circuit breaker, but occasionally you would get maybe 50 amp load demand. let's take a look over here at the trend diagram, and we're seeing voltage on the top, sagging in conjunction with this current on the bottom. So we're seeing like an increase in demand and current and a corresponding voltage sag. So to get rid of that voltage sag, we're going to pull energy from the DC side to help support what's coming in on the AC side. So for example, let's say we're running 30 amps of load demand on our critical load center, and we're limited to 40 input, either by what the generator can do or the circuit breaker protection. And we get this 40 amp load demand in our critical load center. We will pull that 10 amps over on the DC side to support the demand on the AC side. And you can set a program with delay time, what's called connect delay, and it's triggered by the AC input current limit. So you could even set this to, let's say if you were on a circuit breaker at 40 amps and you didn't want to push it to that limit, you could set the input current limit at 35. It's okay, if we ever exceed 35 amps, then we want to start pulling energy from the DC side. Backup mode is primarily used for pass-through and occasional backup power. It just maintains battery in a flow condition. It goes into a standby mode, so it's using very little power. But it has this offset. It can offset the load demand with renewable energy. And this is where that offset feature comes in. Instead of stranding all that power on the roof, it allows your loads to consume that excess renewable energy, but still be in a position to back up those loads completely with loss of grid input. UPS mode is very similar. I'm sorry?
Hey, Mark, sorry to interrupt here. I just had a quick question. So the question was, normally the batteries are not in use when, the batteries are only in use when grid power is not available. Up until that point, are they in float mode constantly?
Yes, the batteries are in a float mode, and it will not offset from the DC side until it hits cell voltage. In other words, once you've pushed the batteries up to a high enough level, it knows that there must be some renewable energy out there that's usable. So it's okay, let's use this renewable energy. The batteries are floating because they have to be if we're up at that voltage level and there's renewable energy, hey, let's use it. I don't know if that answered the question or not. If not, we can catch that at the end if we need additional clarification. So in UPS mode, the transfer speed is 4 milliseconds or less. And this is, if you look at a lot of RFPs for UPSs, you'll see this 4 millisecond spec. Excuse me, with the FX inverter, we weren't able to meet that because we're normally in the backup mode, we're about 12 milliseconds. So there's a small penalty to pay for that. You're not able to go into standby mode, so you have 42 watts of continuous power draw. Support and grid interactive modes are not available, but again, you can offset load demand with renewable energy. So a lot of UPSs, they're just sitting there floating their batteries, and if they wanted to use solar power, it's almost going to waste because the float demand from the batteries is not that great. So if you want to use a lot of renewable energy, it's just sitting there. Whereas with the Radian inverter, if you wanted to use it in a UPS, somebody wanted to go make their data center green data center, their UPS system, they could convert their Radian system, have the performance of a UPS, and they could put up a fairly large solar array that would keep the batteries in float, plus provide green energy, if you will, to run their data servers. So it's very kind of a unique feature. There's also something called mini grid mode, and basically it's set to optimize the utilization of the renewable energy. And offset is also active in this mode, and it will reject the AC source unless the refloat or rebolt set points are met. And what this means is it's going to run off renewable energy power, maybe even bleed off a little bit of the battery power until the batteries are really starting to run down, which is the refloat and revolt set point. Just a moment, I'm going to grab some water.
There was another quick question there, Mark, in regards to the UPS mode. You there?
Yeah.
It was basically wondering whether it was like a true UPS with double conversion or whether it had a 4 millisecond interval start time.
The double conversion part, I'm not sure of, but I do know that with loss of grid power, we are able to switch over within 4 milliseconds. So what happens, there's a couple of different options on the mini-grid mode. If for some reason the DC side is not able to meet the load demand, it will send grid power to the loads if the charger's off. So we'll take a little bit of grid power to support renewable energy side. It's going to, if the charger's on, then it will send power, grid power to the loads and charge the battery if the charger's on. So you have the option, if you just want to say, hey, I want to use all the renewable energy available and just use a little bit of grid power to power my loads if I need it, I can turn the charger off, and what that means is I'm only going to charge my batteries with renewable energy. So it's similar to our, what we call our high battery transfer mode, but it better utilizes the renewable energy and reduces the battery cycling back and forth between grid and battery and grid and battery. So it reduces the charge cycles, but has the same kind of optimization of renewable energy. So the May 3 has been out for, about 2.5 years now. And it's I feel it's a much easier system interface to use compared with our other mate, with its 400 screens and menu structure. This is a much more intuitive menu structure. There's some hotkeys, so if you want to turn your inverter on or off, charger on or off, generator on or off, and just do some quick functions, you can hit these hotkeys on the left, or these ones on the right. The events, if you want to see any errors or warnings or acknowledge them, again, you can go to the AC input, see what the status is. You can drop the AC input if you want, and you can program your own favorites if you want. Your own, if you have a sequence that's deep in a menu, you can record that as a favorite. Then there's these soft keys here that change from menu to menu. This lock key is where you go and to your advanced setups. And it's got a scroll wheel, just like an iPod, and a little inner key there in the bottom. So one of the things that's kind of nice about this is being able to save and restore system settings. So once you've programmed the system, you can save those settings to an SD card. There's a little SD card that plugs in here. It comes with a 1 gig. You can expand up to 4 gigabytes. And you can save those settings away. And what's nice is if the customer system ever goes down, they need to replace, any devices, then they can just restore those settings without having to go through and program them. Especially if your customer is remote, it's kind of nice that they're able to do that. Also, it gives you a record of how you left the system after commissioning, so that you know if something goes wrong later and you suspect the user might have played with the system from the system setting. You can compare the existing configuration with the one that you recorded when you commissioned the system. You can also data log to that SD card. You can do anywhere from 1 second to a couple minutes. The default is to record the data log every 5 seconds, and that's system-wide. So every device that's hooked up to the hub, you can record all the performance data that's available for those devices, and it puts it into an Excel CSV format. And then every hour, on the hour, it writes that file that has those 5 seconds or whatever data log interval you select inside that spreadsheet. So you get 24 files for every day. With a gigabyte memory, you can record probably a year's worth of information, which is probably more than you'd want to deal with. However, I always recommend that whenever you commission the system, you also turn on the data logs, because that's the time when customers still learning the system and system optimization is still happening. It's nice to be able to have those data logs. So if there's a few bumps when the system's first up and running, you can go in and look at the system and see what's going on. Also, there's remote internet monitoring and setup. There's a Ethernet port on the back of the Mate. And I'll talk a little bit more about that shortly. And then this is that configuration file I was talking about. We can go in, if it's hooked up to the internet, we can go in remotely and retrieve it from here at Outback, or you can. This is kind of what it looks like. It's XML, which is a little bit like HTML. And just want to give an example. I was working with a new installer, new to Outback, and the system wasn't running. It was turning off. It was disconnecting from the grid. And he was sure it was the problem with Outback, and I was ready to hop on a plane. And so I said, well, before you do that, why don't you send me your configuration file? And I went through that, and I noticed he had something called low grid transfer mode enabled. So the default is disabled. So he swore that he didn't go in and change anything, but we got this turned back to disabled and solved the problem. So this is just an example of how valuable the feature is, not only to you, but us here at Outback that are trying to help you get your customers up and running. And there could be some coffee there. Okay, here's your kind of your communication options, if you will. The Mate 3 Ethernet port, you can typically how this would happen. Let's say that just you're inside your home, and I do this here at Outback. I've got some equipment set up in our lab that I can reach with my desk. I just have a wireless router, very inexpensive wireless router bought from home, hooked into the Ethernet port. I call it MazeNet. So I have my laptop hooked up into here, and I can look at what's going on in the system just locally here on this wireless internet. Now, if you were to hook up to the internet, you'd probably run this to your main modem that comes in from the outside world, and then you would port forward this device to that main modem or router that comes from your internet service provider. But that's essentially what you can do, and you can do remote monitoring of the system performance, setups, device firmware revisions. You can say, oh, gee, I wonder if they've got the latest firmware. You can check that. You can get it in a formatted web page, but I'm going to show you here in just a second, or on text scripts. So this is kind of like the easy way, but some people want to do more than data monitoring. They want to do control. The easiest probably way to do control is with the Mate 3 USB card, which can plug back into the back of the Mate. Just open that up, plug this in. There's a little knockout that you pull out, and it allows you to monitor, control Outback devices remotely. And so, so this is kind of a simpler way to do it. There's like 50 commands on the rewrite commands you can do. And you can just send this, they're just ASCII commands. It's something you do with a very easy, like quick basic program or something like that. However, the next level is the access port, and this replaces the Mate 3. And it uses a protocol called Modbus TCP/IP. It is an advanced system monitor control. It gives you a lot of power into the system. You can do a lot of things with it, but it does require advanced programming skills. You really need to be a professional programmer that knows C++, Python, or some advanced program. You need to know Modbus TCP/IP, not just Modbus RTU, but Modbus TCP/IP, the Sunspec specification, and you need to know networks, and especially your local network. So it's not trivial, to be real honest with you, but for people that live in this world, especially like up in Canada and oil and gas areas like Calgary and places like this have big SCADA systems and things, they'll be able to handle this kind of thing. But this is not your homeowner, this is your industrial customer. So when you, getting back to the Mate 3, off the Ethernet port, and this scenario I showed you up here, you've got somebody just wants to monitor their system. This could even be a smartphone. You can look at the system using your smartphone. It doesn't have to be a laptop or an iPad, whatever. Somebody doesn't want to always go out to their garage or their shed to see what the system's doing. And so we provide this formatted web page. There's 1, 2, 3, 4, 5, 6 different pages. This is the status page, just showing you by bar graph, how much PV is going on right now. Here's the battery voltage. Here's the battery charging history. Here's the battery monitor currents, that sort of thing. Here's a sample over here on this side of the setups. This is the same information as this. This is a little more esoteric. We can figure it out pretty easily, but in this format, it's much easier for a customer to look and see what the setups are. And again, you can, if you hooked up to the internet, you can remotely monitor that customer system from your office, or we can here at Outback. Now, here's another thing that some people don't want to use this formatted page. They just want to grab the data. There is a way to do that. Normally, if you're on, just like on your local network, you're not going out into the internet, you would just open up a browser, type this in, and you would get those web pages I showed you on the previous page. There's also a little script program in there. If you add this little extension to it, it will shoot back this information right here. And so a person that's writing that has a program could get the data this way, like this port 1, we have an FX inverter. Port 2, the device is a charge controller. Port 3, the device is our flexible DC monitor. So let's say they wanted to go to the FNDC and look at the battery voltage and how much power. So this little descriptor here shows out kilowatt hours today, and the value is 170 watts. That B is the battery voltage, 24.5. So they can parse through this data and grab the little things that they need fairly easily. They can also put the port forward to Mate 3 and just listen for the updated data once a second. So they don't have to pull the data with this command. They can just put their device in the listen mode and just capture the data that way. So I'm going to switch gears a little bit and talk about AC coupling. This is a typical grid tie inverter with PV going in and AC coming out on out to the grid. And I'm sure you're all familiar with how that works. We can retrofit our battery-based inverter into the system. The way this would normally work, this shows a grid loss condition, but let's say the grid was active. You have the PV being inverted. It's going to pass through our inverter to the critical load center. Anything that's not consumed by the critical load center is going to go on out to the grid. Now, if there's a shortfall, if there's not enough PV, then you'll get energy coming this way from the grid tie inverter, as well as energy coming in from the grid. And when there's a balance, a surplus of power, then it goes back this way. Now, in a grid loss condition, the grid tie inverter needs a grid to sync to. So essentially, our inverter, via the battery power, we're in invert mode, we become grid to the grid tie inverter. So it's able to keep inverting renewable energy from the array, comes down, feeds, meets load demand. Any shortfall of load demand that the grid tie inverter can't meet, we will meet with our inverter. Now, if there's a surplus, that energy will come back in an unregulated charge back onto our batteries. And because it's unregulated, because we think we're inverting, not charging, we have to have a way to sense this, which we do with our aux port, and we have to disconnect this grid tie inverter so we don't overcharge the batteries. So that's kind of the key to how we do this. Now, a lot of people have used, external devices, solid-state relays, mechanical relays. They use transfer switches, all kinds of different things that are external, cumbersome, and expensive. So what we did is we came up with this device called a remote-operated circuit breaker. Now, this is a motorized lever here that can move up and down with the signal from the aux port. So, and it's gained with the L1 and L2 circuit breakers, and so it's going to open and close these circuit breakers. And then there's a relay that feeds this, as well as a grid tie inverter lockout relay, which I'll talk about in a second. But it's very simple. This is inside of our load center. For the grid tie connections, you just bring in the L1 here, the L2 here, the neutral, and the ground up here, and that's it. Now, if you want to have add a generator to the system, then you would connect those here. Now, this is one of the things that I worked on for a couple of days figuring this out. I know you don't want to have a grid tie or a generator trying to be the grid source for the grid tie inverter, because if you ever get a surplus of energy, it's going to come back onto the generator and blow it up. So we did figure out a way to lock out the grid tie inverter when the generator is running. But anyway, in terms of installation, it's just 6 field connections, maybe only 4 if you're not going to use a generator. And just use our standard load center with this little device here and these 2 relays. There's also new AC coupling, made 3 function, and a quick start guide that shows you how to hook things up. We have some advantages. We have some smart ROCD, that's remote operated circuit breaker control logic. To get into the AC coupling function, you just select AC coupling and you say yes. There's no settings to adjust. It just works off the whatever the current charge setting is. It goes 0.4 of a volt below that. It opens up the circuit. Above that setting, it opens up the circuit breaker. If it drops 0.4 below that setting, then it reconnects the grid tie inverter. But one things we did to try to figure out, okay, what could go wrong with this system? And one of the things we came up with is we open up that circuit breaker, but you can mechanically override. You can just close it back again. So, well, what happens if the user goes in there and says, oh, gee, this is supposed to be closed, I'll just close it. We check every 15 seconds to see if that's the case, and we'll turn it off. So they try and reconnect it, we turn it back off. Likewise, when it is off and the grid comes back, the system will never see a trigger to reclose and reconnect the grid tie inverter. So we have a grid sense. If we sense that the grid is back on the grid input, then we'll say, oh, okay, let's go ahead and close that remote operated circuit breaker in case it happens. So we've put a lot of thought into this and making a smart system. And again, it's a very simple, fairly inexpensive way that we've come up with to do this AC coupling. The other thing is, if you do need to manually disconnect the grid tie inverter, you can manually open that circuit breaker up. So you can use it to manual disconnect. It's less expensive than using external relays and transfer switches. I know somebody that likes to use solid-state relays externally, but he keeps them in a normally on position, which means there's always power being used by it. He has these heat sinks for over 6 kW. So this, there's no parasitic power on this. Simple to install. There's no diversion loads required. We also use temperature compensated charging set point, which is nice, especially if you live in extreme environments like Canada can be at times. It's nice to use the temperature compensated set points. We have dual AC inputs, so if you want to use a generator with the system, you can. And we have this Gen Start relay lockout. And most frequency shift solutions. There's some that use the frequency shift to knock out the grid tie inverter. In other words, they'll take it outside of its frequency range because it has to be between 60.5 and 59.5, something like that. And if they put it outside that range, then that'll shut the grid tie inverter off. The problem is that also shuts the battery-based inverter off. Generator comes on. All of a sudden, now there's a signal source that the grid tie inverter is going to try and hook up to. May not even hook up to, but if it does, and again, if there's surplus energy not being consumed by the load, you could backfeed that generator and blow it up. So we feel like we've got a pretty good solution there. And then also there's the path for using our, if you want to bypass our inverter, you can implement our integrated bypass system and the ROCB in a way that you can bypass our system completely. So just to summarize, we have this new load center, which is the node-operated circuit breaker, the control relay, the gen start lockout relay, and only a couple of field connections to make. We've got this new phase decoupling function with the smart control logic using temperature compensated set points. And because of this fairly inexpensive ROCB technology, we're able to make it cost-effective and simple, and no parasitic load. Again, the dual AC inputs ensure we have safe generator operation because the lockout. So it's very I feel like we've really come up with a fairly simple, easy way to implement this for those that are interested. So that package would look something like this inverter, the AC coupling load center, the MAID 3, and a set of batteries. And we're pretty much good to go. So that's all I had. I want to thank you for your time and attention today, and go ahead and open things up for questions.
Excellent, Mark. Thank you very much for presentation. Very well done. And we do have a few questions. And before I get to them, I'd like to take this time to thank everyone for coming, and also mention that we have our Harvesting Solar Electricity Day of Training in Calgary on October 3rd. If you're wanting to learn some more about Outback's products as well as many others, that will be a full day of grid tie training, and that will be coinciding with the CANSIA conference, which would be on the 4th. So please give us a call if you have any questions about that, and if you want to type in anything right now as well. It looks like we do have a few questions coming in, Mark.
Here, Cameron, I'll field them just because I've bantered a couple back and forth. So the first question, Mark, is how many AC circuits in a 120-240 load center are there available? So basically asking how many AC breakers could you fit into the load center?
Okay. There are 10 breaker positions, but because it's a 120-240 system, obviously that's going to, there's double pole breakers. So you can put 5 double pole breakers in the top section. And so usually that's 2 double pole breakers for the bypass, and there'll be another set for the input. So basically that would be 6, and that would leave you 4 positions or 2 sets of double pole breakers. And down below we have 8 slots there. Typically people use those for the DC side, like if you're using charge controllers with PV, our ground fault detection interrupter circuit breakers. They're all panel mount breakers. These aren't DIN mount. They're panel mount breakers. They're standard Outback panel mount breakers. So to summarize, 10 on the top, 8 on the bottom. And you can them
and for clarification of that, most people will generally just use the bus bars off of this and go into a sub panel or a main panel.
That's correct. Yeah. Yeah.
So the secondary, there's another question coming in for whether someone can just put a Radian into an existing grid tied setup and without altering the existing grid tie system.
Yeah, that. Yeah, I'd say the answer to that is no. I mean, obviously, this can take some modification, but it's not quite as bad as you might think. So you're just going to move where you would tie into the main service panel. You would take that L1, L2, neutral and ground, and you would just move that into our load center. Okay? So then you'd have to have a new, lines that would go to your service entrance from there. And then you would have a critical load center that would, would feed. So you might have to move some of those loads from the main service panel to the critical load panel. But if there's room right next to the main service panel, that's usually not that big of a deal to do, because you can splice inside of a main service panel as long as it's not a junction. But if it's just to extend the wire, you can do a splice in the main service panel.
And we got a question regarding stacking Radians for an application of a much larger off-grid system in the 30 to 50 kilowatt range. What are the stacking capabilities of the Radian on a maximum scale, et cetera?
Yeah, to keep it on a single system, the limit is 10, which is limited by our hub. By the end of this year, we're hoping to have our new generation hub where you could actually daisy chain 3 hubs together and have up to 30 devices. But right now, the present limit is 10. However, we have seen somebody design a really amazing custom system that actually used 20 Radians. Obviously, that would be 2 separate systems. They had AC coupled into a backup generator, wind power, PV. So, obviously you can do custom designs, if you know what you're doing. But I would say, the practical limit is 10, and then you'd have to do your AC busing externally.
Right. To clarify, there would be other integration hardware required, such as your bypass assembly, et cetera.
Yeah, you'd have to use an external bypass. The bypass that comes with our load center, that's just for a single load center. As soon as you get into 2 or more Radians, then yeah, you'd have to have an external bypass. You could, people have done, because our terminal bus bars and load center, they're rated to 180 amps. I've seen people, use 2 Radians together and do the busing between 2 load centers, and I think that's practical to do. Beyond that, really, you'd want to use external busing. Combining your AC inputs and outputs externally, and then an external transfer switch for your bypass.
And there's looks like there's only one more question, unless anything else is rolling in. The question is, are all Outback products CSA approved?
Well, yeah, I can't say that. It would probably is on an individual basis. I know they're we'll have our equipment is UL 1741, and I don't know how much that, and what they'll do is they'll say UL 1741 certified, and then CSA approved, which isn't the same as being CSA certified. So, I'm probably the wrong guy to really answer this question, and, probably better to follow up with me, and I can find out specifically what products, or if there's a series of products that are in there. But typically, UL and CSA recognize one another. And when you see CSA approved, It just means that, they're essentially the same, but it doesn't, I think when it gets certified, that means that was the agency that actually did the testing, if I understand that correctly. So, but follow up with me, shoot me an email, and if it's an issue, we'll figure out exactly what the correct and best answer is.
Sorry, there's a couple more trickling in. Two of them I'll answer offline. Just see this last one. The last question is specific to Ontario. It's basically saying, are the grid connections and battery backup features approved for use in Ontario? They are, but only under net metering currently until Microfit changes their rules on battery backup. So I don't know if, Mark, you're very familiar with the Ontario program.
I am to some extent, and there's no way that our battery-based system should be excluded from that, but I think that they
I completely agree, but currently all
yeah.
battery-based are, and it's a bit of a fight. So they're hoping to get that changed around. But I haven't seen anything on the books saying that they're allowed in Microfit 3.0 or anything like that.
Yeah, it's an education issue. We're going through this with Southern Cal Edison as well, and it's just they just don't understand. And a lot of it too is one of the local utilities here, Puget Sound Energy. They came up with some metering schemes. There's a 3-meter scheme that they use for what they call Outback inverters, and it's an A plus B minus C metering scheme where it will always subtract out any energy going into the battery will always get subtracted out, anything going that direction. So there is a way you can meter it to make sure that you're not, loading up, you're not doing
a generator or something.
So there's a way you can meter for it. But again, it's just, it's an education thing. I'm not sure we're there yet, but there's no reason why we couldn't do it, technically speaking, but policy-wise, we still need to get that worked out.
Okay, that looks like it's it. So again, thanks for your time for putting this together. Cameron, do you have any final comments?
Yeah, everyone, thank you again for joining us today, and thanks to Mark for the presentation. Very well done. Looking forward to Calgary, and hopefully we meet a bunch of you there as well. So thanks again, and thanks Brian for the heads up on all of that information as well.
And on behalf of Outback, I want to thank everyone else for attending, and Brian and Cameron for your support.
Excellent. Everyone have a great day, and we'll
have a good one.
See you and talk to you soon. Cheers. Bye.